OMG, this unit is gonna be so gnarly and absolutely totally radical because it's about radicals. I'm gonna go surfing and just think about how radical all these radicals are gonna be. Okay, sorry about that. But in all honesty, this unit would be a lot of fun. It's all about the square root function, and the fancy word for square root is the radical. So let's get started on simplifying square roots. Before we get started, let's do a quick review on perfect squares. Here we have the first 20 perfect squares, and obviously there's an infinite amount. It goes on and on forever. But remember what it means to be a perfect square. It just means that if you take the square root of these numbers, you get integers. For example, the square root of 196 is 14, and the square root of 400 is 20. Now, there's actually more to the perfect squares than we've discussed. There are also perfect squares that involve variables with specific exponents. Here we have x squared, x to the fourth, x to the sixth, x to the eighth, and so on. Those are also perfect squares. Now, you should notice that the actual numbers of the exponents are not necessarily perfect squares, but the term as a whole is a perfect square. And here's why. When you are taking the square root of a number, let's say the square root of 25, well, we know that's 5, but another way of writing square root is taking 25 to the power of 1/2. That's the same thing. So let's think about what it would mean to take the square root of x to the 8th. The square root of x to the 8th is the same thing as x to the 8th to the power of 1/2. And we all know this property of exponents: when you have power to a power, you multiply your exponents. So this would give you x to the power of 4. So the square root of x to the 8th is x to the 4th. Let's do another one. X to the 14th. The square root of x to the 14th is the same thing as x to the 14th to the power of 1/2. So really you just end up multiplying your exponents by 1/2, or cutting it in half, which would equal x to the 7th. So as long as the exponent is even, that means you can cut it in half, therefore it's a perfect square. Okay, we're going to get into simplifying square roots, and here's why we simplify. If you look at this top part, we have 1/2 equals 5/10 equals 12/24, 9/18, 35/70. There's an infinite amount of ways to write fractions. So, you learned a couple years ago that you always want to write your final fraction answer in simplified form. Therefore, we all have the same answer instead of an infinite amount of possibilities. The same thing is true for square roots. The square root of 8, if you would do that in your calculator and get a decimal, you'd get the same thing if you had the square root of 4 times the square root of 2, or 2 times the square root of 2. There's all these different ways of writing the same number. So just like fractions where we simplify them, there's a special way to simplify your square roots, so we always have the same answer. Okay, we are finally ready to actually start simplifying radicals. So here we have, for our first example, the square root of 192. We want to simplify that. So if you look first, 192 is not a perfect square. It's close, but not quite. So what we want to do is find factors of 192 in which one of the factors is a perfect square. And then sometimes a number might have more than one perfect square factor, and you always want the greatest one. So what I always do is I take 192 and I just start dividing it by some numbers until I get a factor. 192 divided by 100 doesn't work. 81 doesn't work. If you divide 192 by 64, you get 3. So I'm going to break this up. The square root of, instead of 192, I'm breaking it up into the two factors. 64, which is my perfect square, times 3. And then you can take the square root of both of those. So you have the square root of 64 times the square root of 3. And the square root of 64 is our perfect square, and that's 8. So we have 8, and then we leave this as the square root of 3. So the square root of 192 simplified is 8 square root 3. Okay, here's my next example, the square root of x to the 7th. So we want to break this up into two factors where one of them is a perfect square. And when you're doing this with your exponents, if it's an odd number, you simply just take the number just below. One less. So we want to break up x to the 7th into two factors, and one of them is a perfect square. We simply just break it up into 1 less than 7 is x to the power of 6, and then times what gives you x to the 7th? It's just x. So now we can take the square root of both of them, the square root of x to the 6th times the square root of x. And the square root of x to the 6th, remember you just cut that in half, so it's x to the 3rd times the square root of x. So the square root of x to the 7th simplifies to x to the 3rd times the square root of x. Okay, now our third example, we have the square root of 45a to the 5th. So we have to break apart 45 and a to the 5th. Neither one of them are perfect squares. So to do this, what are my factors of 45 in which one of them is a perfect square? Well, I know 9 times 5 is 45, so I'm going to break 45 up into 9 times 5. And then a to the 5th, I want to break up, and when you have the exponents, you always subtract 1. So we have a to the 4th times a. So I break them up, and then I can take the square root of all of them. And what I like to do, just to shorten up my steps a little bit, I circle my perfect squares. These are my two perfect squares. And when I square root them, when I square root 9, I get 3. So you're going to have a 3 that comes out in front. And then the square root of a to the 4th, cut your exponent in half, so it's a squared. They come out, but this 5 and the a stay underneath the square root. So 3a squared times the square root of 5a. Okay, now we're going to do 3 examples where we will be multiplying two radicals together and then simplifying. You always have to have your final answer in simplified form. Well, first we have this little rule that if you have the square root of a times the square root of b, you can multiply a times b together and then take the square root of them. So first example, the square root of 8 times the square root of 12. Well, according to our rule, we can multiply 8 times 12 together. So the square root of 8 times 12, and 8 times 12 is 96. So we have the square root of 96, but that's not our final answer because we want that simplified. So what factors of 96, which one of them are perfect squares? So let's take 96 and start dividing it, crossing out the ones that don't work. When you take 96 and divide it by 16, you get 6. So I'm going to break that apart. The square root of, instead of 96, I have 16 times 6. And then I like to circle my perfect square, because when I take the square root of it, it goes out in front. So the square root of 16 is 4, and then what's left underneath the radical is the square root of 6. And right there is my final answer. Okay, example number 2, the square root of 5a squared times the square root of 10a to the third. So let's start. Let's multiply everything underneath the square root together. So we want to do 5 times 10. So now we have the square root of 50, and then a squared times a to the third. Remember, when you're multiplying powers with the same base, you add the exponent, so this is a to the fifth. So now after you multiply, we have to simplify, and neither of those are perfect squares, so we have to break them apart into our perfect squares. What can we break 50 up into? If you look here, oh, well, I know 25 goes into 50, so 25 times 2. And then remember, when we have our variables, you just subtract 1 if it's an odd number. So we have a to the fourth times a. So we break it up into our factors. I circle my perfect squares, because when you take the square root of them, they'll be just regular numbers out in front, and then 2 and a will be left over. So the square root of 25 is 5. And the square root of a to the fourth is a squared. And then I'm left with a 2a underneath the square root. And there it's simplified. Alright, last example of the lesson. 3 times the square root of 2b times 4 the square root of 10b. So we have numbers that are outside of the square root. We have numbers and variables inside of the square root. So if you look at our rule, that only applies to things underneath the square root. So we can multiply 2b and 10b together. And then the 3 and the 4 are just regular old numbers on the outside that you can multiply together. So it's kind of like we're going to multiply the coefficients, and then you're going to multiply whatever's underneath the square root together. So 3 times 4 is 12. And then the square root of 2 times 10 is 20. And b times b is b squared. So now we have to simplify this square root of 20b squared. So how can we break apart 20 into factors where one of them is a perfect square? See, 12 out in front. 20 can break up into 4 times 5. And now b squared is already a perfect square because the exponent's even, so we don't break that apart at all. We just leave it as b squared. And now I circle my square roots, or my perfect squares, sorry. And remember, when you take the square root of them, they go out in front. So I have 12 times the square root of 4 is 2. The square root of b squared is b. The square root of 5 is the only thing left over. One more step, and that's just to multiply 12 times 2. So let's write my final answer up here. 12 times 2, I've got 24. B square root of 5 is my final answer. I have to admit, I absolutely love simplifying these radicals. This is one of my favorite lessons. It's kind of all new stuff for you, so it might be a little confusing at times, but push through it and enjoy it. Good luck with the lesson.